Okay, if you're watching from home, we just got started. You can get caught up with our list for today. This is going to be Wednesday, November 4th. Properties of ionic compounds. We've already got started with first statement that an ionic compound is designed as a repeating pattern of the ions that compose it. Also, the pattern is indicative of the ratio the ions are present in. So what the heck do I mean by all this? So let's take a look at one of the easiest ionic compounds you guys will see all year, sodium chloride, NaCl. You see that you have the element sodium, you have the element chlorine, which as an ion is called chloride. This is a 1-to-1 ratio. So what this means is the pattern of the actual ion is going to be a repeating pattern of 1 sodium to 1 chlorine, 1 sodium to 1 chlorine. So to try to draw this, I want you to pay attention to this little design I'm going to do. So every green circle I draw, that's going to represent a chloride ion. And every, let's see, what color should I use? Every red is going to represent a sodium ion, okay? So every sodium ion is going to be surrounded by a chloride ion. So we have sodium here. Actually, why don't we just do the circles to make this a little faster? You got a sodium here, chlorine here. You got a chlorine there. You got a sodium here, sodium, and then chlorine. It's just a repeating pattern. And this is a 3-dimensional shape. So if I were to go 3D, I could go here, there's chlorine. Let me move this out of the way because that's in my way a little bit. If you guys kind of look at this, it looks like a cube. This is called a crystal lattice. And this is indicative of all not polyatomic ions. This is indicative of all ionic compounds. In an ionic compound, you have a repeating pattern of the cation and the anion, but I want you to know that this is the ratio in which they are presented. So in a compound like sodium chloride, it's going to be 1-to-1. But if I had a compound like sodium nitride, it would be 3-to-1. So for every 1 nitrogen, there would be 3 sodium surrounding it. Also, if you were just wondering why do I have the chloride ion bigger than the sodium ion, well, a chloride ion has 18 electrons, a sodium ion has 10 electrons, so sodium is just a smaller ion. So a crystal lattice is a 3D geometrical arrangement of ions in an ionic compound. I believe this is one of your vocab terms. Whoop. Okay. Are there any questions with that? All right, moving on. Let's go to physical properties of these compounds. So some physical properties include melting point. This is the the temperature at which a solid becomes a liquid. You all know that melting means you're going from a solid to a liquid, I hope. You got boiling point. This is the temperature at which a liquid becomes a gas. And then you have hardness. These, a lot of these have metals in them, and so they can be, a little harder than others. Another one is going to be conductivity. This is another physical property. This is the ability to attract heat or electricity. Typically, in order for an ionic compound to conduct electricity, it needs to be in the liquid state. Or here's a new word you haven't heard of before, aqueous. Aqueous means dissolved in water. When you have Gatorade, what is Gatorade famous for having inside of it? Electrolytes. Electrolytes are actually going to be salt, potassium, calcium. They're called electrolytes because they basically help conduct electrochemical signals in your nervous system to communicate with your muscles. During the summertime, when football season starts, like in September, you'll often see a lot of players fall on the field because they have a muscle cramp. They typically have a muscle cramp because they're sweating so much, and we all know that sweat is salt in it. It tastes salty. They're sweating so much that they really don't have any electrolytes left. And so what happens is their muscles begin to contract uncontrollably, and they can hurt. They can really contract. And so what they'll do is they'll bring you to the sideline. They're going to fill you up with Gatorade and fill you up with water to try to get your electrolyte balance back in. And what that's going to do is that's going to let your nervous system, which is your brain and your spinal cord, be able to effectively communicate with your muscles so that you can tell your muscles when you want them to contract and not just have them contract whenever they want. A lot of football teams, both high school, college, and pro, they will have tons of Gatorade and Powerade on the sidelines. They'll have a big box of bananas on the sideline because we all know bananas have potassium. Potassium is an electrolyte. But in the NFL and in college, something that we really can't do in high school is if you have a really bad cramp, they're going to bring you back to the locker room. They're going to stick an IV in your arm and basically pump you with salt water. And that's going to get your electrolytes right into your bloodstream. And you'll be back in 5 minutes. When your grandparents were in high school, and let's say your grandpa played football, they would give them a salt tablet. It was a literal pill, looked like a big aspirin. It was literal salt. And they just say, take a salt tablet, and you eat the salt tablet, and that gets all the electrolytes back in your body. So it's better when they're dissolved in a liquid. That's what Gatorade is all about. You basically have that salt tablet, but it's dissolved in a drink. And it's much easier to conduct those electrical signals when it's in a liquid or aqueous form. Aqueous means it's just dissolved in water. Any questions on that? Okay. So the purpose of this, when it says conductivity, it's able to conduct electricity. Biologically speaking, some ionic compounds serve as electrolytes. They can conduct an electric current. And if you didn't already know, where was Gatorade invented? The University of Florida. That's why they call it what it is. You will not see Gatorade on the sidelines of Florida State. They use Powerade, just probably because of that one reason. Florida is a very, very hot place, and they noticed that the players were getting very, very, very fatigued early on. And so the science department of University of Florida tried to come up with a solution to their players getting heat stroke and cramping and overheating, and they invented this drink that has dissolved electrolytes inside of it, and the players drink it, and the cramps kind of go away. Gatorade was born, and now Gatorade is a billion-dollar industry. Okay, but what electrolytes do, and if you didn't really hear me out, is that electrolytes basically allow your nervous system, which is your brain and your spinal cord, to effectively communicate with the muscular system. You know, Colby plays football. I would always ask him for the JV scores. Football players, volleyball players, basketball players, y'all get cramps. You're sweating so much, you don't have any electrolytes left. Electrolytes are things like salts, sodium, potassium, calcium, magnesium even. You got to put back what you put in. And so what a good coach will tell you is drink a lot of water during the day, just straight up water. And then after practice, drink H2O, because while you're sitting in your chemistry classes or English classes, you're not sweating, hopefully. So you don't need to worry about losing salt. Just drink water. But after practice, and you've been sweating like crazy, then you drink Gatorade. And one mistake I used to do, when I first started teaching, my voice would get really sore, and I was a big fan of Gatorade. I would have the big half-gallon Gatorade. And then I looked at the nutrition contents, and I saw just how much sugar and salt is in them. And I realized if I keep drinking these, you know, I might get something like kidney stones, because they can build up in your kidneys. All that salt and all that sodium is not good for you. And so I kind of snapped out of it. I was like, oh, stupid. So I just switched to drinking water, because I'm not sweating. I'm not losing salt. Why put more salt in my body? I don't want to have too much. So just a little tip. A good coach will tell you to drink water during the day. Drink it like crazy. And then after practice, drink the Gatorade to put the electrolytes back in you that you just sweat out. In fact, that used to be one of Gatorade's commercials. You know, replenish what you've lost. Something like that. Well, if you're sitting in class, you haven't lost anything. All right. Well, I want to go back to melting point real quick. Melting point and boiling point. I want to show you guys just a few melting points and boiling points. A melting point is going from a solid to a liquid, and a boiling point is going from a liquid to a gas. Have you ever had creme brulee? Creme brulee is a type of pudding. You can go to Burns, they'll make it for you, where you have this pudding and you have a layer of sugar on it. Sugar. And you get this little blowtorch you keep in a drawer, and you blowtorch the sugar, and the sugar melts, and it's really crunchy like glass, and you can eat it. Sugar is a molecule. It is held together by bonds that we have not talked about yet called covalent bonds. That is weaker. Now, that little blowtorch probably gets to a couple hundred degrees, and that melts sugar. Well, for something like salt, table sugar, if you wanted to melt that, you would need to get it up to 801 degrees Celsius, which is definitely above 1,000 Fahrenheit. That's pretty hot. And if you actually wanted to make salt boil into a gas, you would have to get it up to 1413 Celsius. Another compound that is an ionic compound is magnesium iodide, Mgi. If you wanted to melt it from its liquid form into its solid form into its liquid form, you would have to get the temperature up to 2852 degrees Celsius. And if you wanted to actually boil it, it would have to be up to 3600 degrees Celsius. So the point I'm trying to make to you all is ionic bonds get weaker when going from solid to liquid and liquid to gas. But here's the catch. Ionic bonds are incredibly strong. It takes a tremendous amount of energy or a tremendous amount of heat to break them. All right. We are going to stop there, and we will pick up with properties of ionic compounds tomorrow. I think that's a good place to end it. The bell's going to ring shortly. All right, to be continued till next time.